Hello everyone. In this video, we are going to study about the sparse matrix. So when we call a matrix as a sparse matrix, if the most of the elements of the sparse matrix have zero values, then it is called a sparse matrix. So you can see here the values inside this 4 by 4 matrix. We have only 4 values which are non-zero. So total we have 16 values. If we have more than 8 values as a 0, then we can say this matrix as a sparse matrix. Okay, so the 0 values which is of no use, then the sparse matrix can be a drawback to us. So we can represent the sparse matrices by some other representation that will save us the complexity and the traversal time also and storage also. So there can be many ways in which we can represent the sparse matrices. We will discuss about the two ways, that is array representation and linked list representation. In the array representations, we will try to represent a 2D array in the form of 1D array. So why? This is because zeros in the matrix are of no use. So storing zeros with non-zero element is wastage of memory. To avoid such wastage, we can store only non-zero elements. And if we store only non-zero elements, it will reduce the traversal time also and the space complexity also. So both we can reduce time complexity and space complexity. So how do we represent the array, the 2D array in the 1D array form? So here you can see three values. Here we are representing row, column, and the value. Row means the index of the row where our element is present. And column is also having the index because it's a 2D matrix. So let's suppose same example what we have discussed in the last slide. So in this example, you can see here the value which is pointing to 7 is the value which is A of, it is 0, 3. You can see this is 0, 0, 0, 1, 0, 2, and last one is 0, 3. And this 3, 3 is present at the index 1, 1, because this is 1, 0, and this is 1, 1. This is 1, 2, and finally, this value is pointing to the A1 of A1, 3. This value will start from 2, 0, and A of 2, 0 is this value. So these are the four values which is there in our matrix, which is non-zero. So we will try to represent these four values only, and we will ignore the zero values. So here we will make a table in which I will write the row index, I will write the column index, and the value which is present at the row index and column index. So first value you can see from this matrix is 0, 3. Means 0 is the row index, 3 is the column index. And the value which is present at A of 0, 3 is 7. Next one is the 1, 1. So row index is 1, column index is 1, and the value present at this index is 3. Let's store 3 here. Next value is 1, 3, and 6. So 1 is the row index, 3 is the column index, and 6 is the value. Next is 2, 0, and 8. That is 2, 0, and 8. So this is the complete table in which we have stored the row index, column index, and value. Now, if you want to represent this matrix in the form of 1D array, so I will make a new index like 0, 1, 2, 3. So this new index will be your one-dimensional array now. So I can say that if A of 0 now is present at A of 0 is having value 7. A of 1 is value having 3. A of 2, 6. A of 3 is. In this way, we can save our computational time and we can say traversing time and space also. Second way I can represent is the linked list. So in the linked list, you can see here, we are storing four things: the row value, column value, and the value which is having the value of the matrix. And the next node means the address of the next node. So if you don't know about the linked list, let me draw one simple linked list in which we are having, let's suppose, three nodes. This is the first node, second node, the third node. Okay. Initially, this first node will be called a start node, or we can say this is the head node. Okay. Just having some value. Let's suppose this value is 6, this value is 7, this value is 8. And then this field will represent the address of the next node. It will point to the next node. In same way, in every node, the second field is representing the address of the next node. In the linked list, let's suppose this is the last node, so we don't have any next value. That's why it will point to the null value. So how do we represent all of these? So linked list, as you know, that it is a dynamic data structure, and we can create the nodes of the four field also. Right now, in this simple linked list, we have created only two fields, but if you want to create four fields, you can create the four fields also. Let's suppose first field will have the row index, second field will have, let's suppose, column index, third field will have the value which is present at this row and column, and then last field we can say is the address of the next node. So in this way, I can represent all of these values using these nodes. So what will be our values? So if you represent row, column, and value here, so values will come is 0, 3, 7, and the last field is having the address of the next. So in this way, we can represent all the non-zero elements using the linked list form. So in these two ways, we have represented the sparse matrices. So sparse matrices can be represented in other ways also, but these two are the most important ways in which we can represent the values. So as I already explained the advantages, that it will save the memory, it will reduce the traversal time, and we can say computational complexity, and faster matrix operations can be performed when we do in scientific computing, machine learning, and graph algorithms. The applications in the graph augmentation, we use adjacency matrix. So there also we can use the sparse matrices. Second is image processing. In the image processing, when we represent any image, that image will be in the form of matrix. And that matrix will have some pixel values, and the values which is in the detailed form, maybe that is only our images. Otherwise, all the values can become 0. So there also we can use the sparse matrices. Then machine learning and AI. So in image processing, you already know that we are using that. In the same way, we process these images using machine learning or deep learning algorithms, then these value will be used here also. That's why sparse matrices have many applications in the real life scenarios.